Hello everyone, I'm Karthi Vignesh. In this video, we're going to talk about exercise number 10 in Research Notebook and Compiler Design Lab, which is the intermediate code generation. So in this video, what we'll be doing is we'll be doing the simulation of the intermediate code generation, which is the third step in a compiler design, which is sometimes lexical analysis, syntax analysis, and the third one is the intermediate code generation. So basically, the intermediate code generation is nothing but when there is an expression, for example, a plus b star c, we know that we should be following the precedence and we will be doing b star c first, and after that we will be doing a plus c, a plus the b star c, b star c's output, and we'll be adding it with a. So we know that the precedence should be followed, but the computer doesn't know how to follow the precedence. So we will be resorting to intermediate code generation, which basically segregates the complex expressions into simple ones, and they will be given with three variables and two operators, which is one any calculation operator and an equal to operator for the assignment. So that's what an intermediate code generation is. And in our program, this should be the sample input and the sample output. The sample input is given like this. A sample output is basically the smaller expressions of this complex expression, and it will be outputted to the user. So this is the program that I have written for it. So in this one, I've given the operators here, and I've given the priority for each of the operators in this dictionary. So after that, I'm defining an infix to postfix function, which basically does what, as the name suggests, it will convert whatever you input into the program into a postfix expression. So after that, we'll be having this function, which is generate. In this function, we'll be using using the technique that we follow. This is basically the technique that we are following to generate the three code generation. What we are doing is, after converting to postfix, we are going through it, and we are doing the same exact thing. We'll be following in our theory when we are writing it ourselves for the intermediate code generation. We are following the same thing to form the intermediate code generation, intermediate codes using this one. We're basically forming triples here. So after that, these are two functions, and I'm getting the input from the user in the expression, and I'm storing the infix to postfix output in POS variable, and after that we are generating from the POS variable, which basically prints us the output one by one. So I'm going to execute the program now. So let's I've earlier said that a plus b star c. We'll just go with the same example. So here we know that b star c should be the first one. So after that, a plus b star c. As you can see, that's how the program also works. So I'm going to execute it again with a different input. So I'm going to give a plus b, let's just say a star c plus b plus c minus b. A star c should be the first precedence, and plus or minus have the same precedence, so it doesn't matter what we do first. So it is taking the plus first, which is the first occurrence, and then it's going for the minus, the second one. So that's it for this program, which is exercise number 10 in Systems Program Compiler Design Intermediate Code Generation. So thank you for watching. See you guys in the next lab.